and topic has been selected with binding snake robot based on double spiral drive. So let's get started. So this is me, self-introduction. My name is Salam Zubairullah and I'm from Bangladesh, and mechanical engineering my major, and my supervisor is Chen Tpic. So today I actually categorized in 4 parts. First of all, I need to tell the first content is project design and background. We need to first understand what is the project design and what is the background of my design. What is the main basis of design that I actually working on. Then structural design modeling. Structural design modeling, we will see that how actually we model that according to the structure and motion. Then control system design and commissioning, and finally project application prospects and future innovative ideas. Project background and design ideas. So we know recent years the earthquake is unavoidable natural disaster. So my design is mainly based on earthquake disasters, and when earthquake happened under the rock, there are a lot of people suffering. They cannot the rescue team cannot take them out. So my analysis is how we can send a snake robot there to charge the system and give the information. So that's the main prospect. So over the years we have seen the earthquake is like our cars in our day-to-day life. So after an earthquake we can see that this collapsed building inside it is very difficult to find the information. So in that case, if we think how we can take the information from the earthquake-prone areas, only based on the snake robot, we can take the information under the very critical and unstable movements. So snake movement analysis. First of all, we need to analyze the snake movement. Snake movement is actually serpentine motion. It actually locomotes with the serpentine angle. So we know that snake has a muscular body with zero gravity, and when it crawls on the ground, it has spread the body like spreading everything over there, and then by pressing their body muscle, they actually go forward. So this is the deep analysis of snake robots are heavy and large in size. So that's why we need to think in differently how we can develop a snake design. So here you can see Uncle Sam, the snake robot, is a very famous robot in USA, and it has been designed with different motor and body structure with part connecting each other. But my design is actually helical drive, double helical drive or helical gear. You can say. You can see in the picture here. The helical motion actually has 2 phases. One is clockwise and another is anti-clockwise. So clockwise motion gives that force to this direction, and another one is giving force to this direction. 2 forces give a resultant force along with the movement direction. And it can also move left, right, and go up and down by wire connecting system. So I will share you more and more if we go forward. So deep analysis releasing the flexible binding movements of snake-like robots. So here is a very important thing that we need to understand first. The thing is wire connection, cable driven snake robot. How we can bend a snake by wire connecting or pulling wire connecting system. How we can see this is a wire connecting system with a microcontroller. When we pull the connecting wire, then this part is getting very closer and this part is very wide. So in that way we can make a curve. So when we making curve, we can change the direction according to it. So along with that idea, I have built this wire connecting system. You can see this wire actually can control the snake position, changing their feet according to need. So we will go and see how that actually works. So design task flow that I displayed how I actually design. First of all, if I say binding foundation, how did I do the binding foundation? By ventral scales of snake body. Snake body has ventral scales that make the body to make a friction with the ground. So that's the ventral scales. Under the body belly of snake, you can see that ventral scales is very fricted and it can make a friction on the ground. So that's the vertical scale. And the snake's backbone and rib is very important. Then design basis and overall performance indicators. So within this idea, I actually added the part by part of the snake body. Then overall design, program design. So structural design is the main part. Then control system also need a control system, because only a structure cannot be a snake can easily can't move. Then structural design, environmental adaptability, speed, performance, flexibility, flexibility, drive mechanism design, transmission mechanism, design of deformation mechanism, and for control system, hardware design, software design, environmental adaptability test, and finally the prototyping. Prototyping is the printing out. I actually printed out and tried to make a simulation according to the design. One of the Chinese students, he actually helped me a lot to do this project, so I actually very thankful for him, but he couldn't come today. He has other works to do. So structural design and modeling, we'll discuss it. Let's see how actually design the structure. First of all, let's introduce my snake. This is head or tail, whatever you can say. This is also head or tail. That means it can move from forward, backward, or backward, forward. And this is the main part, is the power unit servo motor. From this servo motor, the power unit, that the angular acceleration generates from here. And I made a double helical so that we can make the left movement and right movement very smoothly. How we can make the left movement and right movement? By rotating the left side, it can generate the force, total force to this side, and this one will be stopped. When it is stopped, when it is rotating on the left side, it will turn to comes to the left. And for same case here, when it is rotating, this part is not working. So this servo motor has two ends. One is this part and another is that part. So when it is making the angular motion, it can rotate according to the need. And also there are some sensors that I have used here, the speed sensor, and for connecting the wire, I have also used a sensor which is called Hall effect sensor. So compared with the existing snake robots at home and abroad, already has made the following innovations in the movement snake-like robots. So I have already mentioned that my snake is double helical. Drive mechanism was designed based on the snake belly scale. So flexible transmission mechanism designed based on the snake spine. So snake spine is also very important. And the wire control mechanism was designed as based on the contraction muscles of skins. So double helical drive mechanism design. So we need to understand the main basis of the motion. Here, the forces I have analyzed here, the distributed forces, GV, GH, and GML, which is horizontal reaction force, vertical reaction force, and medial reaction force. This is snake body, so one part of it I can actually make this kind of force distribution. So design flexible transmission mechanism, how actually I did according to the snake ribs and spine, you can see, snake ribs and spine. So it is very well organized, and mainly snake has muscles, but the robot has no muscles. So I need to design in a unique way so that it can really move. The most important part of my thesis defense presentation is wire control mechanism design. It is very important to understand why wire control is very important, because when we control the snake from left to right, forward to backward, but we cannot control how the snake can make the head up by wire control system. By pulling the wire, the snake can be pulled in, like if it is like this, the snake can be pulled on that way, then we can overcome this obstacle. So that's why wire control mechanism is very important. And control system design and commissioning. Now we will discuss about the control system that must need for the controlling snake robot motion. So the control system that I can show you, input is Bluetooth module, and we can see the microcontroller. We have used Arduino Uno Nano and voltage module, regulating module, steering gear drive, and 360 steering gear rotation. So I have already told that it was the gear that stiff motor I have used, and Hall effect sensor, which is 3144E that I have used. This is the control system. I can show you. This is the feedback. This is a practical feedback given by the Hall effect sensor. Without Hall effect sensor, we cannot make it a closed circuit control system. This is a closed circuit control, closed loop control system. You can see that, and actual action is happening here, and feedback sensor is giving the feedback to the controller. And also we can make it a Bluetooth connected control system from phone. From my phone, I can control the robot from here to operate the robot from left to right or above. We can do whatever it is. So hardware selection. So how we select the hardware according to the control system that I have designed is AC Bluetooth, HC06 Bluetooth module. This one is a combination. I actually got it, and then Arduino Nano Master Plan, and then regulating module, the PMW servo, and also the 360 degree rotating steer gear, and then finally the Hall effect sensor that give the feedback. Particularly software control program. So I need to make it very clear to that without software programming we cannot control the system. So we need at least programming control the system. So for that, for feedback, this one is feedback for 3144E Hall sensor to take the change the magnetic field at a fixed position and the angle control of the text up will and realize through the algorithm. In that way, actually, it is being adaptive, sensitive with the present situation. According to situation, it actually can be changed according to the obstacles. So debugging and running, how we can run this thing. First of all, in the app, we can understand that there are some manual steps to control. First of all, left bending, right bending, up, forward, back off, lift, right shift, and stop. To do that, we need to do the fine tuning over there, where you can see. Sorry that I didn't bring that snake here, so I really apologize for that. So this is the video that I need to show you. This is the simulation video.
First of all, we can see that this robot is moving forward. You can see this is a lateral drive, it's moving. Counterclockwise, this is clockwise and moving forward. And you can see this is the wire connection with the Arduino. And this is moving forward because of the double helical drive. It can move very smoothly in a rough place. And this is a very rough place that we actually took it as a demo. Like this is a place where you can take a lot of friction here inside. And it can move forward, backward, on the right side, left side, and the height can be up. So right now we will see the left and right motion. Yeah, you see, it will right and so left, and it will come right. So let's check. The head is going up. When there will be an obstacle, it will be up, and it will come after above the obstacle. Very easy because it's very smooth in very rough places. You can see in front over my hand, it already took it over. So in this way, it can any obstacle situation, any difficult situation, situation that cannot a robot enter, it easily can enter through it. So that's the thing that I wanted to show for this spiral drive. It is made by the double helical. Also, you can see the movement of the serpentine motion that we actually studied. Serpentine motion is like the snake body motion. That way we have designed, and it's very flexible in any kind of situation. So that's all. We would like to conclude here.